statistics revision. So some of the things that you need to remember for your test or for your exam. So let's start with the measure of central tendency. Under measure of central tendency, number 1, we have mean. So we denote mean using X bar. So mean is the sum of all the scores divided by the number of scores. So number 2, we have the mode. Mode is the most appearing value in our data set, or we can say it has the highest frequency. So number 3, we have the median. So median is the median score in an arranged data set. So that means for you to find the median, you need to make sure that your data is arranged from the lowest to the highest. And then the median number is your median. So now let's look at this example below. So in this example, the first question, we are required to calculate the mean. So now the mean is given by X bar is equal to the sum of all the scores divided by the number of scores. So in this case, if we add all these numbers, so we are going to have 43 plus 55 plus 58 plus 62 plus 62 plus 65 plus 70 plus 75 plus 85 and then plus 92, and then you divide by 10. So how many numbers are here? They are 10, so we divide by 10. Now our numerator will give us 667. So we have 667 divided by 10, so which result to 66,7. So 66,7 is your mean. Sometimes in the exam it is called average. Now question number 2, determine the median. So the median is the median number in an arranged data set. So we need to check if our data is written from the smallest to the highest. Fortunate enough, we can see that our data is already written from the smallest to the highest. However, you will realize that our data is even. So we have 2 medians here. So we have 2 medians. So there are 2 numbers in the middle, which is 62 and 65. So if you have 2 medians, we are going to add these 2 numbers. So we are going to have our median as 62 plus 65, and then we divide them by 2. So our median will be 63,5. Sometimes in the exam you will get the data that is odd. So if the data is odd, that means you are going to have 1 median. However, if there are 2, you just add them and divide by 2. And then the next question here, write down the mode. So mode is the most appearing value. So now if you check here, so the only number that is repeated is 62. So 62 appears the most. So you just write your answer as 62. So 62 is our mode. It is the one that has the highest frequency. So that is your measure of central tendency. And then number 2, let's look at the measure of spread. So there is also the measure of spread that you need to remember. So under the measure of spread, number 1, we have the range. So the range is given by the maximum or the highest value minus the minimum, which is the lowest value in your data set. Number 2, we have interquartile range. So interquartile range is given by upper quartile. So upper quartile is Q3 minus lower quartile. Lower quartile is Q1. And then we also have a semi-interquartile range. Semi-interquartile range is given by Q3 minus Q1 all over 2. So basically, it is the half of interquartile range. And then we also have standard deviation. So for standard deviation, you will just use a calculator to find your standard deviation. So this is a notation for standard deviation. And then now let's look at this example here below. So the first question in this example, we are given the very same data that we have used above, and then we are now required to find, number one, the range. So for the range, you just say the max minus the minimum. The maximum value minus the minimum value. In this case, it is 92 minus 43, which will result 249. So your range is 49. And then question number 2, determine the interquartile range. We said the interquartile range is given by upper quartile minus lower quartile. So now, if we check here, what is upper quartile? Remember, we said we have 2 medians. So these are our medians. Now, the median will divide your data into a lower data set and your upper data set. If you have 2 medians, one median, which is 62, will belong in a lower data set. One median, which is 65, will belong in an upper data set. So now Q1 is the median of this lower data set. So Q1 is the median of this lower data set. And then Q3, which is the upper quartile, is the median of your upper data set. So now if you look at your lower data set, your median will be 58. So your median will be 58. That means your Q1 is 58. If you look at your upper data set, the Mealy number in an upper data set is 75. So that means your Q3 is 75. So now that means your interquartile range will be 75 minus 58, which will give you 17. So that is your interquartile range. And then number 3, standard deviation. So if you are looking for standard deviation now, this one will depend on the type of calculator that you are using. But if you are using a K-show, so if you are looking for standard deviation, number 1, you'll press mode, and then you will choose stat, and then from stat you choose one variable, and then from one variable the table will appear, and then you insert all your data. After you have done that, you press your AC, you press shift, you press 1, and then you press 1, you press 4, and then after you have pressed 4, standard deviation will be number 3. So this is the notation for your standard deviation. And then now we are done with the measure of dispersion. So let's move to the 5-number summary and the box and whisker. So 5-number summary consists of 5-number number 1, there's minimum. Number 2, there is maximum, the highest value. Number 3, there is a median, which is your Q2. Number 4, there is upper quartile. which is your Q3, and then number 5, there is a lower quartile, which is your Q1. So that is your 5-number summary. So now from the above data, we said our minimum is 43. We said our maximum is 92. We said our median is 63.5, and then our Q3 is 75, and then our Q1 is 58. And then from this 5-number summary, we can draw box and whisker. To draw box and whisker, we start from the minimum. Our minimum is 43. So 43 is somewhere here. You need to indicate this is your 43. And then we have our Q1. Our Q1 is 58. So 58 is somewhere here. So you need to indicate that we have 58. We have our Q2. So our Q2, which is the median, which is 63.5. So 63.5 is somewhere here. You need to indicate we have 63.5. And then we have our Q3, which is 75. Our Q3 is 75. And then we have our maximum at 92. So 92 just after 90. So here is 92. So you need to indicate this is 92. So here is our box and whiskers. So that is your box and whisker. Now, from this box and whisker, you must be able to comment on a spread or comment on a skewness. So now, there are so many methods that can be used to comment on a skewness. So the easiest one, if you do have your mean and your median, it is very easy to comment on a skewness. Now, if the mean is bigger than the median, so you must know that your box and whisker is positively skewed. So if your mean is greater than the median, your box and whisker is positively skewed. But if the mean is smaller than the median, your box and whisker will be negatively skewed. If the mean is equal to the median, we say our box and whisker is symmetrical. Now, if we look the box and whisker that we have drawn above, so you will check that, or you will realize that our mean is 66, our mean, we got 66.7, which is bigger than 63.5. So that means that the box and whisker that we have drawn above is positively skewed. But if you check with the box itself, you will then notice that our Q2 is so close to Q1. So our Q2 is so close to Q1, then it is close to Q3. So our box and whisker it is positively skewed. So now if I were to draw a box and whisker that is negatively skewed, it will be something like this. You will have your Q2, which will be more closer to Q3 than it is to Q1. So this one is negatively skewed. And then the symmetrical one, you will see that your Q2 is exactly in the middle. So that one is symmetrical. Now, We are done with 5 number summary and box and whisker and commenting on the skewness. And then now let's look at the scores within, outside, below, above the number of standard deviation of the mean. Now, number 1. So in your data set, some of the scores that you have, or the data that you have, is within, it can be outside, it can be below, or above the number of standard deviations. So now let me start with the scores that are above 1 standard deviation. So in the exam, if they say above, you are looking for the number of scores above, they can say 1 standard deviation. If they say above, we use x bar, which is the mean, plus 1 standard deviation. If they say 2 standard deviation, for 2 standard deviations, we use x bar plus 2 standard deviation. If they say 3, where there is 2 or where there is 1, you just put 3. So now we do have our mean. So here you just put your mean. You just put your mean here, and then plus you put your standard deviation. Let me see what is our standard deviation. So our mean is 66.7, and then plus 1 multiplied by our standard deviation is 13.7. Our standard deviation is 13.7. Now, if you calculate this, 66.7 plus 1 multiplied by 13.7, you will get 80.4. Now, amongst the values that we are given, you will check how many values are above this number. So that means the first number will be 90. So let's go back and check. So we are looking for all the numbers that are bigger than 80.4. So how many are they? So you will realize that it is 85 and 92. So 85 and 92. So they are true. So the number of scores that are above 1 standard deviation from the mean, you will say, therefore, they are 2. You do not mention them. If they say how many are they, you will say they are 2. So the answer is just 2. 2 scores are above 1 standard deviation. Now let me go to below. Below 1 standard deviation. Below 1 standard deviation. So if they ask you below, you use x bar minus 1 standard deviation. So you are going to have 67.7 minus 1 times 13.7. Remember, they can ask you 2 or 3 standard deviations. The only thing that will change, where there is 1, we are going to put 2 if they say 2 standard deviation. And then if they say 3 standard deviation, where there is 1, you are going to put 3. That is the only difference. Now, here we get 53. So we are going to check how many numbers are smaller than 53? So we are going to count all of them, and then those are scores below 1 standard deviation. So let's go back and check from our data. So below 53, so it is only one number, which is 43. That is the only number that is below 53. So now that means there is only one score that is below 1 standard deviation. So the answer here is 1. So the answer here is 1. And then there is also above. So above basically is the combination of below and above. I mean outside. There is also outside, not above. There is also outside. I have already discussed. Above. So now outside. Outside 1 standard deviation. So outside 1 standard deviation, we use x bar minus 1 standard deviation. The upper limit is x bar plus 1 standard deviation. And then from this, we will get 53. And then from that one, we will get 80,4. So we are looking for all numbers that are smaller than this, but bigger than that. So how many are they in total? They will be 3. So because this is the combination of the above and below. And then the last one is within. So within is the opposite. Within is the opposite of outside. So now everything that is not outside will be within. So that means the number of scores that are within 1 standard deviation, they are 7, because the scores in total, they are 10. So the ones that are within will be 7. So the last thing that I want to speak about is outliers. You must be able to identify outliers. So now to identify outliers, we use Q1 minus 1,5 IQR. So we said our IQR is interquartile range. We also use Q3 plus 1,5 IQR. So anything that is smaller than this is an outlier, and anything that is bigger than that is also an outlier. If we can go back to our calculations, we said our Q1 is 58. So just say 58 minus 1,5. And we calculated our interquartile range as 17. So we said our Q3 is 75, and then plus 1,5. And then we calculated our IQR as 17. So if we calculate this 58 minus 1,5 into 17, we get 32,5. So 32,5. So that means any number that is smaller than 32,5 is an outlier. We can also calculate our upper limit, so which is 75 plus 1,5 into 17. So this is equal to 100,5. Any number that is bigger than this is also an outlier. So now if we check our numbers, the minimum is 43. So there is no number that is smaller than this. the maximum is 92. So there is no number that is bigger than that. So that means there are no outliers in our data set. No outliers. Because outlier, we are looking for all the numbers from our data that is bigger than this or smaller than that. So we do not have such numbers. So that means there are no outliers in our data set.